Did we grade 7-3? Are you guys double checking real fast? Yeah, okay. 7-4. Here we go. Number 2, improper. Number 6, letter C. Number 8, letter A. Number 2, improper, then C, then A. Number 14 and 22 we can check out. Number 14, you did not have to solve. Read the directions carefully. On the test, you will have at least 1 or 2 multiple choice. You will not have to solve. You just have to break up into partial fractions. Number 22. Hey, he was a repeated one. Nathan, this is like, you see the building? I just remember that we talked about that. Number 22. Break it up, but then we have to solve. Guys, just real quick, what method did they end up using? You see it. What method is that? Well, you could have done the thumb trick, but what did they actually end up using? You didn't mean that. The thumb is a good thing. I don't know. Yeah, thumbs up. That makes sense. Anyway.
Thumbs down.
Oh.
Now then you have
Based on
chaotic,
context,
chaotic neutral thumb.
Wait. Can someone just tell me what from the notes? What do we call this? Strategic values. Thank you. All right. Did anybody get confused by the fifth thing? Okay. Remember, they wrote this in the nice factored form. Real quick, you could have not put the fifth out here. Sorry, I forgot that I was going to tell you this. Just pretend that's scribbling. You could have put 4/5 there and 1/5 there. That's right. That's not wrong. They just don't like the complex fraction. And to be honest, I guess I don't really either. So they pulled that little over 5 or the 1/5 out in front. Does that make sense? So I don't mind if you put 4/5 1/5. That would be also correct. This is a beast. Hopefully you guys did it easier than they did it. They did strategic values. No, they did like terms. They did like terms. They had the cubed one, they have the squared one, they have the x one, and then they have the constant. I would have done strategic values. I would have done strategic values, then maybe some of the like terms. But you guys noticed, that's a lot of foiling. And this one has like 3 that are easy, like multiplying together. You could have done strategic values. It probably would have been easier for number 36. You could have plugged in -2 and +2, and then maybe like 0 and 1 if you needed to. Long story short, A was. Let me just zoom in. That didn't help. I need this one. That didn't need too much. Final answer is -1/6 over x plus 2, 1/6 over x minus 2, 1/3 over x squared plus 2. The x term ended up being a coefficient of 0. C was supposed to equal 0. At the end of the day, they went ahead and made it look. My mouse doesn't like anything. They made it look a little bit nicer by bringing these down as fractions, bringing the little denominators down. And then they pulled out a 1/6, but they couldn't pull out a 1/6 until they changed him. So they made him a 2/6, and then they pulled out all the 1/6. So that's how they got their nice, pretty answer. It's not bad. It's actually quite a bit simpler looking, hopefully. You would agree, but this answer is just as good. But as I would say to my calculus kids, you might have a correct answer, but like in multiple choice questions at a test, the question is, can you make it match? Can you take what you got, if it's right, and realize it's the exact same thing as this guy? Can anybody help us out real quick? If you do have this one, and if you don't know how to simplify to get that one, is there a strategy you could use, like say this was a multiple choice answer? You could like plug in 1 to this and plug in 1 to that and see if it matches. That's a good strategy. Anybody have another one? If you don't know how to go from here to here.
They look pretty close.
They look pretty close, that's true too. Could you multiply into 1/6? What's 1/6 times 2? 1/3. What's 1/6 times 1? 1/6. 1/6 times 1. Maybe that would also help. You don't always have to go from the question to the answer. You'd be able to go backwards as well. Alright, that's enough time on that. Number 44. Wait, hold on. Number 36 was huge. Why was 44 so short? They didn't do the problem. Yes, they did. If you you tried to keep going, what would you have had to do with this leftover remainder piece after long division? Split them up, but how would you split them up? Partial fraction, what would you use? Factor the denominator, right? So anybody, exactly. If you try to factor the denominator, factors of 6 that make 1, 2, and 3, but I need a negative. I can't have a negative. Well, 1 and 6? Nope. I need a negative for anything. So, wait, just because it doesn't factor, does that mean that there are no zeros?
No.
No. So you could have kept looking if you were willing to do the search. But if you tried to plug in the quadratic formula, you would have had x equals negative b plus or minus square root b squared minus 4ac. As soon as you start plugging in 4ac, what do you start seeing? Who is this? Imaginary, perfect, it's a negative number under a square root, imaginary. This guy has no real roots, so forget him. He can't go any further, and if he can't go any further, we can't break him up, and if we can't break him up, well, I guess that's as simple as we can get it. Dun, dun, dun. Dun, dun. There is no further to go. There is no further to go. Alright, 7-4. Done. 7-5. Anybody have any quick questions on calculators? You weren't supposed to use it on the whole homework, but you were supposed to use it every now and then. People, if your apps are gone, you're able to use the shading above and below. Okay. Number 14, you have a line with an intercept of what, -5 or something like that? A slope of -5/3. Solid line because it's equal to, shaded above because it's greater than. Number 26, that was just a strict using your calculator, but you can't use your calculator until you solve for y, or x, I suppose, if you use the app easily. Solve for y and then shade, less than, below. What should be the boundary line? When you graphed it, what should this look like? The boundary line should be dotted. Double check. Boundary line should be dotted. How'd you guys do 44? By hand or with a graphing calculator? What'd you do? Didn't get in Calc Chat, it wasn't on there. If you did it later, oh my goodness, that's wasting time. It's faster to do on your own. Okay, no, that's not totally bad. So if you did use your calculator, this bottom one is easy to solve for y, right guys? Subtract the 4x, divide by -3. What did you have to remember on the first one?
You gotta put 2 equations.
2 equations. Why 2 equations? You square root and you put in a
Circle
plus or minus. Subtract x squared plus or minus square root. Hopefully no one killed a puppy. When you square root 25 minus x squared, it is not 5 minus x. Algebra 1 kids yesterday and today are learning the puppy rules. Hopefully they remember them enough not to make any mistakes later. Although all we could talk about after me saying the puppy rule yesterday was like, I ate a puppy once, and like, I don't even want to know. Anyway, then it turned into I ate an octopus, and I ate squid, and I ate this, and I ate that. So I'm not sure if the bad math kills works with algebra 1 kids. Anyway, coming back. We got distracted for a while.
You get distracted sometimes too.
That's true, but not as much as 9 weeks. Anyway.
Squirrel.
Did you find out the name of
It's a
Mr.
compliment.
Shinks'
That's how I always take it.
Did you find out the name of Mr. Shinks' new kid?
Jimmy.
I'm running down the
Charlotte.
Ricky, he didn't name it Ricky.
I don't think he did.
Jimmy
No, he has
J.
interesting
Not
names
Jimmy.
for all of his kids.
What?
Paxton, Reed,
Milo.
Milo, and Neil.
Fourth baby.
No, his name for baby, his fourth baby is baby.
Fourth baby, I ran out of names.
Alright, you guys at check 54?
Mr. Coleman himself.
I'm sure you take that as a compliment because his heart for people that believe in Mormonism is huge. As big as ours should be for people that
Also believe in Mormonism.
don't know Christ. At least not the real Christ. Alright, cool kids. Any quick questions on homework? I know I minimized it, but it's so close. Any odd? Any other evens? Okay, no, it's fine. Which one? Anything on 7-5? Let's start there. Okay. Anything on 7.4? 63 on, oh, 7.5?
Yeah.
Okay. Anything else? Alright, I'm gonna get number 63 ready, but meanwhile, while I do, you guys, I'm gonna have you start writing 7.6, section 6 notes.
Whoa.
I'm coming back. So you get the book loading, and hopefully it likes me today. Alright,
So,
there you go.
I
No.
think it's a kind of an equal opportunity,
Oh,
data.
is that what's going on?
Oh, wait.
It's already not working, that's a bad sign. I'm coming back. Is it gonna work, yes or no? Yes. Okay. For all of you that were bundled from outside, sorry. It's kind of warm in my class today. Let's try not to fall asleep.
We should just hold a nap day, so maybe that day students.
You guys know if there was a nap day, you just watch Netflix on it anyway.
But there are they
Yeah,
should-
I would definitely watch Netflix on my
Or
own.
video
That's
game
the
all
thing
day.
I can do.
But then maybe students would have a higher output from some things.
That's true.
Here's the point.
They
If
do
you don't
take it.
use the time that you have to rest, how are you gonna use it if we give you more time?
Exactly, so I think it's
Rest.
The question is, and this is actually from my own heart too, the question is, what do you do with the time that you aren't doing the work that you're supposed to do?
Rest.
Some can answer that, and I'm proud of them if they can.
Sometimes
There
I
are
fall
many
asleep.
that do not use that time productively, so is the answer really getting more time? Now, I also do totally believe that there have been, that the faster our society is getting paced from year to year, there have been extra expectations put on you guys than necessarily in previous generations. Although, back in the day, high schoolers did hold down side jobs. So maybe time was just spent differently. Differently based on societal expectations. It's hard to know what responsibly is now. Like, is just because you guys don't have jobs, a lot of you, does that mean you're not responsible? No, not necessarily. I'm just saying. There used to be more odds and ends types of jobs that you could do. Well, way back when, it used to be everything was harder, so the entire family had to work together in order to be able to actually make it through the day. Like working a farm, or working a ranch, or working a family business, etc. And some of you do still do that, depending on what your families are involved in. But I do agree that time is harder to get. I totally agree with that. Or that more is expected because things have become easier. In the sense of with technology, there's more expectations placed on, even with friendships and things like that. Relationships, new expectations come. But I think the bigger question isn't how to get more time, because to be honest, we only have 24 hours in each day. The question is how to use it more wisely. And that does not mean working nonstop. God gave us a day for rest for a purpose. All of us, myself included, are not always wisest with the rest of them that we do. Something to strive for, and something to praise the Lord for grace. Alright, let's go look at number 63 real fast. You guys have had lots of time to write. do hear the struggle. I do sympathize with the struggle. I think the way I do homework and the way I do deadlines and the way I do guys training hopefully signify that I get the struggle. Hopefully signify. But I also do give us room to learn how to deal with our tendencies to procrastinate. And hopefully we learn how to deal with those and to succeed despite being given looser deadlines, because that's what college is going to be. Of course, you do homework every night, and to be honest, most college classes don't even give many points for homework. I had a class once where even though there was homework assigned that would prepare us for tests, the grade was solely based on 4 tests, 25% each. Let's just say there was a little bit of freak out before those tests. Until I aced the first few rounds. Alright, come back. Number 63 gave us something weird. It was an application problem to business. Consumer surplus and producer surplus. Business is a really cool field to go into, but you will have to make it through a business calculus class. Just saying, keep working on your math. It's okay. It'll get you to where you need to go. Graph the systems representing the consumer surplus and producer surplus for the supply and demand. Ooh, supply and demand. That's an econ thing. 12th grade. Anyway. Equations and find the consumer surplus and producer surplus. Wait, hold on. They give us equations, right? What can we see P as? What variable?
Y.
He's like our Y. He's like our dependent variable. X is like our independent variable. We can graph both of these linear equations, right? These linear equations, what are they going to have? An intersection point. And what are we trying to find? Graph, that's A. Find. How are we supposed to do that? Kiddos, real quick, just since we're talking about the whole trying to learn how to deal with responsibility and deal with college, etc. Teachers in college also, not to scare you, just to prepare you, expect you to take some initiative in solving, or in doing homework, or in researching, or in reading to prepare for tests. Those of you that hate the teachers that give you reading, they're trying to prepare you for what's coming. Anyway, was there an example in your book that had to do with consumer surplus and producer surplus? Aha. So I would follow this example because it is going to help us out. Let me just quickly look at it and see if there's any questions you guys have on the example. We graphed both of our lines. You guys can see them by the diagonal lines. They had slopes. When you graph them, you do find an intersection point, and at that intersection point, you make a horizontal line, a y equals, which you actually can graph as well if you want in your calculator. No, I'm fine. I did that. Whatever this y value is at the intersection point, extend it to be a horizontal line, and then to find the producer surplus and the consumer surplus, all you gotta do is say, hey, he's a triangle. And how do we find the area of a triangle? 1/2. Do you see it down here? Yeah. 1/2 base times height. And how do you do that? You look at each triangle that results from your graph. The height will be how far from the height of the intersection to the highest point or the intercept, or the intersection point, that height to the intercept if it's below. Take that distance, that will be the height. And then you take the extension, the x value, which will be the base. So the x value of the intersection point is the base, and then the difference or the change in the y values is the height. Does that kind of make sense how to set it up then?
Yeah.
Okay. So graph it, intersection point, extend horizontal line, and then you use your graphs to figure out how far is the x value of the intersection point and how high. You have to subtract the y values, the y value with the intercept, and then you just go ahead and do 1/2 base height for one. Consumer is above, and 1/2 base height for producer, which is below. Alright, kiddos, with that, let's go ahead and go back to 7-6. 7-6, the nice thing is there's not really anything, there's no new math that's required. No new math. But there is a new application. So, we're going to start it today, finish it tomorrow, grade it on Monday, and be ready to go for our review. If you guys are able to, which I think I'm going to be able to teach you most of the section today. If you can, since there are no games or anything tonight. If you can get this homework done tonight, then you can be working on your review over the weekend, which would be a great idea. Okay? Alright, 7-6. Long story short, we're trying to find the max or min of something. We're trying to find the max or min of something. And when we find the max or min, that process is called mathematically optimization. And I think we talked about this a little bit earlier when we were finding the max or min of parabolas. This obviously is a bit more complicated than a parabola, even though some of you would rather do this than do complete the square. But this is a bit more complicated in that we have a lot more than just a parabola. But optimization, finding the optimum, we're finding the max or min. Remember our example from before? Cost. What would be an optimal cost? Keep it. Cost. What do you want that to be? Low or high? You know this, right? Optimal cost. We want it to be low, so we would find the minimum cost. Or if you want a profit, what are you going to do with that? Yeah, you want the high. You want to maximize that. Okay, just depends on the problem as to whether you're doing the max or min. You guys have already written down it's an optimization strategy. What is this linear programming process we're going to talk about? A few special terms to have down when we talk about an objective function. The problem's not always going to say like, hey, ding, 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 here's the objective. It might just give you words and you have to pull out the objective function. But the objective function is just whoever you're maximizing or minimizing. It's kind of the point of the whole problem as to what you're trying to find. And the constraints are the restrictions that you're bound by, whether it's life restrictions, whether it's finance restrictions, whether it's like personal restrictions based on like standards, etc., or convictions. But constraints are the different restrictions that are placed on a situation or a problem. And in our case, those constraints are going to be linear inequalities, which we reviewed in 7.5. I know. There's a lot of writing to begin with, and then we're just practicing till the end. So hang in there, one more page. But as you guys do this page, if I were you, if you're a highlighting person or a starring person or a boxing person, this is a key idea. I would even say the key idea of section 7.6. The key idea you have to remember is that to find the optimal solution, aka, if we just said the optimal is going to be either the max or min, find the optimal solution, aka the max or min, we're going to have to check or test all the vertices. We're going to have to test or check all the vertices. So you might even want to extend. You might even want to extend this highlighting to be for the bottom as well. The top is the main idea, but if you were one where you're like, okay, the main idea is all well and good, but I want to know how to do it, maybe you should highlight the whole thing. If the max or min must occur at a vertex, then we have to test the objective function at each of the vertices. And here comes the dilemma. How can we test them if we don't know what they are? We can't. So we have to find the vertices, and that's just the steps. Sketch the region, just like you did in 7.5. Number 2, find the vertices. Number 3, test them. Find the winner. Winner, winner, chicken dinner. Find the winner, find the lowest, find the highest. And that's it. We're done. I was one of those teachers. I would throw up an example that's totally solved and be like, cool, follow the process. Go! Some of you can do it. It's not really my style. So let's work through 1 or 2 together. Try to get a feel for it, and then I'll leave you guys to trying and practicing it. Oh, you guys are tired and tired? rest, I don't know, the black hole was just not there anywhere. The girls did a great job. Honestly, you should get your friends to go. And you can have fun hanging out while you're like, sitting there supporting. I know the tickets cost money, but the girls are doing a great job. Okay, how many of you guys went to Friday's game? Yeah.
One.
Oh, we don't ask. Okay. I was live streaming it. I didn't get to be there. That was an exciting game though. Huh? Yeah, I worked the clock for the home game, so I got to be at Tuesday's game and Wednesday's game. And get in for free. And get paid.
Yeah. So that's why you were there.
I liked it. Girls game Saturday. It's at home. Just. Alright. Here, I should have this all written down by now. Do you guys have like tests today? Is that cool?
Huh?
No, it's just a Thursday.
Last Friday.
Alright. Here we go. How do we do it? Good news is this isn't a word problem, so we don't have to like go searching for things. They give it to us. Give you a heads up now on the test. There's going to be at least one of these, maybe a long answer, maybe a multiple choice, but you're going to have to do the work. But maybe, I'll promise you now, one of them is going to be nice, short, simple, given to you. You just have to know what to do with it. There'll probably be another one that might have some words where you have to kind of pick out the clues yourself. Now, kiddos. There are already labels for the different pieces of information out there. I've shown you this guy's the objective. I've shown you these guys are the constraints. But if I was to take that away, if I was to say, okay, that's not even there anymore. Question. How should you have still known that that is the objective? Z equals 3x plus 2y. How did you know just by reading the problem?
Equals.
Well, there's an equals, that's true, but aren't there equals down below? I guess those are inequalities. There's an equals, not an inequality. That's like a quick shortcut way, but what's another way to know? Look at your notes. What did I say about the maximum, the objective function? Yeah, it's the one you want the optimal of, and the optimal means the max or min of. So when you read the expression, when you read the problem, it says max of, ask yourself the question, who? That guy. Okay, then what is that guy? Oh, he's the objective. Does that make sense? So when you read a problem, you hear or you see or you realize they're asking for the max of or the min of, just follow that reasoning and say, oh, who? And then say, okay, that's the objective. And then once you get things with inequalities, yes, that's going to be the constraints. Now, hold on real quick. Theoretically, you guys could look at this and say, stink-a-dink. So this is going to be one that we have to graph. This is going to be another one that we're going to have to graph. And this one's going to be another one that we have to graph. And this is going to be another one that we have to graph. But let me try to just shortcut the process real fast. In most real-world problems, where you're actually talking about quantities of things, talking about finances, it's going to be a little bit different. If you're talking about quantities of like objects, if you're talking about like supply and demand, etc., those first two quantities just say, hey, only look to the first quadrant. Does that make sense? If x is positive and y is positive, we could go to all the work of saying, okay, let's graph y is equal to 0. Let's graph x is equal to 0. And let's say let's shade above. And let's say let's shade to the right. And then let's say, yay, it's that region. But if we can shortcut the process and say, you know what, hold on, wait, we know. If x is positive and y is positive, what quadrant are we in? Got it. We don't have to graph those. Nice. We can kind of just ignore the first two constraints. And they don't always even tell you the first two constraints. So one more time, if it's a real world problem, in the sense of talking about quantities of things, you're not going to have negative of almost anything except for money. Why would you have negative money? If you're in debt, right? If you're in debt. Okay, so then coming on back. So let's ignore the first two. All we have to really stress about for the constraints are the bottom two. I'll make this guy blue. I'll make this guy blue. I'm taking him off to the side because hopefully you guys from last night figured out we need to get y by itself, right? Subtracting x dividing by 2 will be negative 1/2 x. And then 4 divided by 2 will be 2. You guys know what I did, yeah? Maybe you didn't mentally do it with me, but you know what I did. Who did I get by himself? Bottom equation. X minus y is less than or equal to 1, so solve for y. What do we get? Oops. Y greater than or equal to? Real quick, just to review. I added the y, and the y ends up on the, hey, the greater than, the mouth is eating. But if you didn't do it that way, you could have also kept the y where it is, and when you multiply or divide by a negative, what are you going to have to do? Flip them. Alright, I have my two conditions. Let's take them down here and let's go ahead and graph. I'm going to go with my negative 1, the y-intercept. Up 1 over 1. Up 1 over 1. Up 1 over 1. Solid or dotted? Dotted. Oh, I just moved it. There we go. Above or below? Above because of greater than, right? But why am I, even though I'm going above, why am I sticking to the first quadrant? Oh, that's right. Yeah, x greater than or equal to 0, y greater than or equal to 0. Just the first quadrant. Blue, what do I know? This works better when we talk. What do I know?
Slope and the plus 2.
The slope and the plus 2. We start with the
Plus 2.
plus 2. Slope says go down or left? Down 1. Good. Right 2. Hey, look, they intersect. That's nice. That's on purpose. Where am I shading? Below, right? Less than? Why am I just shading there below?
It's in the first part.
Nothing else matters. That's where it overlaps and then we're done. Now, let's go ahead and zoom in on that guy. Is that okay? I'm zooming in on him because in the steps we shade. This is step number 1. Number 2, we find the vertices. What was my silly way of remembering vertices from last section? They are the corners. Everything was or equal to, so I can go ahead and make sure everything's solid. Let's identify them. So hopefully our graph made it super easy to identify, right? We have 0, 0, and yeah, we have 0, 2. We have 5, 0. We have 1, 0. Then who's this guy? I think it's 2 and 1. Do you guys double check? I think it's 2.
Yes.
Those are vertices, and according to our steps, all we have to do to solve is the testing step. And the testing step says, no big dealio, give me a point and plug into the objective. Remember, our point is to find the max. So, our 4 different vertices are going to be 0, 0. In no particular order, doesn't really matter. We're just looking for the highest or the lowest when plugged in. What was our objective function? Z equals 3x minus 2, so we're trying to solve for z. Is it 2y or just 2? Oh. That was good? Mental math, let's go for it. Plugging in 0, 0, we get?
0.
Plugging in 1, 0, we get?
4.
Plugging in 0, 2?
4.
Negative or positive? Does that make sense? So plugging in 0, 3 times 0 is 0, and 0 minus 2 times 2. And then plugging in 2, 1, we get 6 minus 2 is 4. Double check the mental math. So assuming that's right, kiddos, all we gotta do is what? Choose the one that makes my objective be the highest, because it says max. And the highest one is? So we state it as an answer, and here's how to properly state it as an answer. There is a maximum value of somebody at something. We have two different answers, 2, 1, and then 4. Which one goes in the of spot? I wish. Who are you trying to maximize? The objective. So I say the maximum value of the objective is. Does that make sense? It's easy to get confused. Of 4. That's the highest the objective gets. And at or when x equals 2 and y equals 1. Does that make sense? We've gotten through the one where, or the example where they gave you all the objective, they gave you all of the information, they gave it to you all mathematically stated, and all you had to do was say, sweet, let's graph it, find the vertices, plug into a table, dun, 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 oops, choose the highest. Then, dun, 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 dun. But, remember how I said we might have some where they give us all the nice mathematical statements of exactly what we're supposed to do and what we have? Then we have the one where, oh, P.S., we got it right. Yay. Okay. 13 has. Oh. Sorry, I forgot why I had this page. I always forget why I have this page. This is our problem. This is our nice little region, and these are the vertices that we tested, and we figured out that the best point was 2, 1, right? What are all these bottom testings showing us? Are these vertices, any of them? No. None of these are vertices. So we plug them all in to prove the point of 2, 1 giving the highest objective. Wait a minute, what was the highest that we could go? Do you see the problem? Why is this the problem? Check out each of our points real quick. 1, 1 is in the interior, right? 1, 1/2 is in the interior. 1/2 and 3/2 is in the interior. 3/2 and 1 is in the interior. The problem is, none of these are supposed to be higher, but what do I see? That one's equal to, that one's higher, that one's higher. Oh my goodness, am I in some big trouble? So let's go back and double check and say, what did we do wrong? And I think Nathan hit the nail on the head. I was like, guys, it looks good, right? And then what was the problem? You could see the function and I couldn't, and you said yes, and the answer should have been no, because it should have been plus 2y. Struggle. It's okay, we can quickly adjust things just a little bit. I think we still have the right answer, but we have the wrong of. Double checking real fast. 0, 0 is still 0. 3, 0 is still 3. 0, 2 is now positive 4. And 2, 1 is now 8. So now we have a maximum value of 8 at 2, 1. Now let's see if it makes more sense with all those interior points. Is anybody higher than 8? No. Some are higher, some are lower, but nobody's going above 8. Why? Because once again, the maximum value does occur at a vertex, as long as we plug into the right one. We're going to get back to this tomorrow, guys. This is kind of like a special weirdness that could happen. Not could happen, but another way of looking at it with lines. So we'll get back to those special ones yesterday, or no, tomorrow. But this is what I wanted to show you before the bell rings. Hold still. This is a problem? What is your job in this problem?
Give up.
Write the whole paragraph and then pretend like I did it. No. Write the whole paragraph and then do it? No. Whenever we get a word problem, what's our goal? What's our objective? Read through it and pick out the keywords, right? I love that you guys are so prepared and getting ready for the bell to ring. That's not going to ring for another at least 60 seconds, maybe 120 seconds. 190? No, 90 seconds? Anyway, it's not important. Pause. Focus. The more we get done tonight, the less we have for the weekend. We can do our review over the weekend to get ready for our test next week. You get a good test grade in. But, coming back. Whenever we have a word problem, our goal is to summarize, right? And we summarize by saying the important information is. Why did I start highlighting maximize? That's the point of the problem. Maximize who? Ask yourself the question. The combined profit, right? Then if I were you, I'd go looking and saying, well, how do I get a profit equation from the given information, right? We could say profit if I can spell profit. P equals. How do I get profit? See, there's candy going on right now. 150 times, I don't know, however many of those ones, right? Plus $2 per however many of those ones. So we have chocolate covered creams and chocolate covered nuts. There's our profit, but question, are we going to touch this guy right now? Nope, we're going to leave him off to the side and say, okay, you're the point for the table at the very end. What is our goal now going to be over the next 3 problems? Find the constraints. And real quick, even though it's not stated anywhere here, what quadrant are we going to keep it in because they're understood constraints? We're not going to get negative boxes to sell. We're keeping it in quadrant 1. All right, cool kids, see you later. Alligators after wild crocodiles. Work on 7-6 sums tonight. Happy Thursday.